control.
Okay, so this time we will now discuss the different type of loads that you can put on a structure. So the contents is the following. So we have a dead load. The next one is the live load. Next we have the impact load. The fourth one is the wind load. The fifth one is the earthquake load. And we have also the hydrostatic and soil pressure and the thermal and other effects. Then the load combination, so this will be discussed on your higher year subjects. So to be specific, I think mag-start kayo with reinforced concrete design. So what are dead loads? So isang magandang example niyan is yung mismong weight ng iyong structural member. So kung meron kang concrete, you need to consider the density of the concrete, then multiply it by the volume to get the dead load. Or if you want to get the uniform load of that, so i-multiply mo lang siya nung span niya. Okay? O kalahati plus kalahati nung isang side. As discussed, I think this is, kung maaalala nyo yung pagkuha ng uniform load sa stresses in beam from our previous subject na mechanics of deformable bodies. So, basahin natin yung definition ng dead load. So, consists of the weight of all materials of construction incorporated into the building or other structure. So, lahat ng mga bagay na or materials na ilalagay mo doon sa structure, you need to compute the dead load or the corresponding load of that material, including but not limited to walls, floors, roofs, ceiling, stairway, built-in partition, finishes, cladding, and other similarly incorporated architectural and structural items, and fixed service equipment including the weight of cranes. So yan yung mga example ng mga materyales or yung mga structural members na nando sa loob ng isang structure. So yan, meron kasing table do sa ating NSCP or the National Structural Code of the Philippines. So ito po yung parang pinaka Bible ni civil engineer. So later on, papabiling kayo niyan and gagamitin siya sa pagde-design. Next one, weight of the structure itself, the beam, column, and slab, and all fixed elements such as door, window, ceiling, flooring, etc. So to make it short, no. So basta lahat nung dadalhin ng iyong structure, kailangan mo siyang i-consider yung kanyang dead load. It is a gravity load of constant magnitude and fixed position that act permanently on the structure. So ayan, so ito yung ilan sa mga example. So here in table 1.2, so nandyan yung minimum densities for the design load from material. So andyan yung most commonly used material natin, and then given sa kanya yung kanyang unit weight. O it comes to kilonewton per cubic meter. And then for table 1.3 sa minimum design dead load, so there binigay yung kanyang tawag dito, stress. Yan, kilonewton per square meter yung kanyang value. So ayan, binigay yung kanyang mga sizes for walls. So meron kang 4-inch, 8-inch, 12-inch. Ito yung kapal ng ating wall. So dito, this is for clay brick. So I think this is sa US sa ating kasi hollow block. So frame partition and walls, so andyan din. So basahin nyo na lang per material. So ito naman is example pa lang floor fill, you have also ceiling. So guys, always take note na kailangan nyo rin basahin yun na sa baba. So for table 1.2, so the minimum design for design load from material produced with permission from American Society of Civil Engineer or ASCE, minimum design load for building and other structure. So ito is yung reference na ginagamit sa Amerika. And then sa kabila, minimum design dead loads produced with permission from America's Society of... So ganun lang din, galing din sa ASCE. Okay, so let's proceed with the next slide. So a more detailed table for dead loads can be found in section 204 of the National Structural Code of the Philippines or NSCP, Volume 1, 7th edition from page 2 to 12. So guys, ito na yung sinasabi ko sa inyo. No? So ito, mga dead load na to, yung corresponding value niya can be seen dito sa ating NSCP. So, kung meron kayo dyan na libro nito, so maganda, i-browse nyo na rin. Kasi importante yung librong yan. Okay, next, this time we will now discuss all about live loads. So, what are live loads? So, kung dead, patay, stead lang siya sa lugar na yon, kung saan mo nilagay, dun lang siya. Live load, ito yung mga gumagalaw. So, these are loads of varying magnitude and or position caused by the use of the structure. So, ayan varying magnitude and position. Produced by the users of the building. These loads include the weight of the people, furniture, and their storage item. So, ayun nga. So, di ba, if the function of your structure is for example, school, and compared sa structure na, halimbawa lang, yung for the use of commercial use, halimbawa, hotel, ganyan, So, per kwarto naman yan, di ba, pag mga hotel naman, normally, isang pamilya lang yan, kataasan 4, ganun. Most of the time nga, 2 lang di ba? Unlike sa mga structure na katulad ng isang school, kung saan maraming tao yung kino-consider. So, doon, meron siyang table din sa NSCP, meron siyang value ng mga live load depende sa usage ng building niya. So, pag dami ng tao, so syempre, mas malaki rin yung value ng ating i-consider na live load. Generally, its previous definition is any load that is not dead load. So, ayan. So, kung alin yung hindi dead load, yun yung live load daw. However, some non-dead loads like wind and earthquake loads have their probability of occurrence is different than those loads due to the use of structure. So, ito na lang, ang tandaan nyo na lang, pag galing sa nature yung natin, so that is under lang ng wind or earthquake load. But, other than that, if it's not dead, not coming from the nature, so that is live load. Okay, so last, the code treat that other environmental loads like wind and earthquake loads separately from the live load. So, yan lang din yan, yung kapareho nung sa kanina. Okay, so again, we have here the table. So, occupancy or use, ayan nga yung sinasabi ko. If this is assembly areas and theaters, so fixed seats, you have a value of 60 PSF or 2.87. So, ayan lang din yan. So, basahin nyo na lang isa-isa. And then sa kabila, occupancy or use, if this is residential, so ayan nga, meron siyang corresponding value. If schools, so classroom, ayan, may binigay siyang value. So the unit is in terms of stress or stress or ano pa ba ang stress? So, sa baba, nakasulat is minimum live loads reproduced with permission from ASCE lang din. But then, ito may counterpart nga sa Pinas. So, we have here, a more detailed table for live loads can be found in the section 205 of the National Structural Code of the Philippines or NSCP Volume 1, 7th edition. So, same page lang din. Okay, so from that, alternate floor live loads reduction. So, under Section 205.6 NSCP 2015 Volume 1, page 2 to 20. So, the alternate floor live load reduction as an alternate to Equation 205-1. Ba't gumagalaw? The unit live load set forth in Table 205-1 may be reduced in accordance with the equation 205-3 on any member, including flat slab having an influence area of 40 square meter or more. So ito yung gagamitin mo equation, instead of using the 205-1 equation, if the unit load set forth may be reduced in accordance with the equation, including flat slab having an influence area of 40 square meter or more. So if that is greater than 40 square meter, dito yung gagamitin natin. Whereas yung ating AI, influence area in square meter, and L is the reduced design live load per square meter of supported by the member. So again, if this is more than 40, you will use this equation. LO is the unreduced design load per square meter of area supported by the member. So ito is yung manggagaling doon sa table 205-1. So parang kumuha na panibagong value yun kasi mas malaki yung value ng influence area mo sa 40 square meter. Okay? So the influence area AI is 4 times the tributary area for a column, 2 times the tributary area for a beam, equal to the panel area of a two-way slab, and equal to the product of the span and the full flange width for a precast T-beam. The reduced live load shall not be less than 50% of the unit load LO for members receiving load from one level only, nor less than 40% of the unit live loads LO for other members. So nagbigay siya ng condition dyan, so dapat masasatisfy mo yan unless mali yung magiging sagot natin. Okay, so dumako naman tayo sa another type of load, which is the wind load. So ito is yung hangin, kasi kung i-consider mo yung mga high-rise structure, so sumasayaw po siya lalo pag malakas yung hangin. So kailangan yon may sway, kasi kapag sobrang steep niyan, ang tendency niyan magkakaroon ka ng mga failure sa loob, yung mga poste mo bibigay, mag-crack, babagsak. Okay? Okay, so let's define what are wind loads. So wind load result from the forces exerted by the kinetic energy of the moving mass of air, which can produce a combination of direct pressure, negative pressure or suction, and drag forces on buildings and other obstacles in its path. Wind forces are typically assumed to be applied normal or perpendicular to the affected surfaces of the building. Wind pressure increases as a function of wind velocity. The average mean wind velocity for any particular area, measured over a long period of time, generally increases with height. Okay, so habang tumataas pala, mas malaki yung wind pressure na nangyayari dun sa iyong structure. The rate of increase of the mean velocity is also a function of the ground roughness and the interference offered by surrounds objects that include other building, vegetation, and landforms. Okay, so yung wind load mo kasi, if papunta ka sa building, yung mismong harap niya, so that is windward, and then yung kapag likod, that is leeward. So, ayun naman. So, take note lang din, lagi siyang perpendicular or normal. So, lagi siya ng 90 degrees with respect to sa face ng iyong building. So, meron kang tinatawag na transversal area and longitudinal area. Depende dun sa orientation ng wind load na i-compute mo. So, later on naman, i-discuss naman sa inyo yan sa mga higher year subject nyo. So, particularly, that will be discussed in your reinforced concrete design and structural steel. Okay, so let's proceed with the next slide. So variation of wind velocity with height. So explain natin. So ano ba yung sabi kanina, 'di ba? Habang tumataas, lumalaki yung wind pressure mo. Variation in wind velocity with height near the earth's surface, the motion is opposed and the wind speed reduced by the surface friction. At the surface, the wind speed reduces to zero and then begins to increase with height. So, coming dun sa pinaka-bottom niya, so naka-0 siya and then unti-unti siyang lumalaki yung value sa pagtaas niya. With height at the some height known as the gradient height, the motion may be considered to be free of the Earth's frictional influence and will attain its gradient velocity. The gradient height 300 meter for flat ground and 550 meter for very rough terrain. Okay, so based on this diagram, so ayun nga. So this is the effect of wind load on tall structure. So, di ba ito, imagine this as your support. So, meron ka ditong wind load applied. So, di ba, dito sa pinakababa, andito yung maximum shear mo. Kasi ito is free or malaya siyang gumagalaw. Dito lang yung pinaka-support niya, which is a fixed support. So, this will be the shape of your shear diagram, the moment diagram, and this one is the deflection. Kasi nga, di ba sa taas ka, nagkakaroon ng sway. Nakakatakot naman kung dito sa baba, dito ka nagkaroon ng deflection. So, bibigay yung foundation mo dyan. So, dito yung maximum deflection sa pinakataas. Okay, wind effects on structure. Wind effects on structure can be classified as static and dynamic. Static wind effect primarily causes elastic bending and twisting of structure. Dynamic for tall, long span, and slender structures, a dynamic analysis of the structure is essential. Wind gusts cause fluctuating forces on the structure which induce large dynamic motion, including oscillations. So guys, here are some links dun sa ating video. So maaaring naglagay dito sa Sir Jake ng pwede nyong panoorin na reference. So i-share ko na lang and just click the link to view this following videos. Okay? Okay, so dumako naman tayo sa tinatawag na earthquake load. So what is an earthquake load? An earthquake is a sudden undulation of a portion of the Earth's surface. Although the ground surface moves in both horizontal and vertical direction during an earthquake, the magnitude of the vertical component of ground motion is usually small and does not have a significant effect on most structure. It is the horizontal component of ground motion that causes structure damage and that must be considered in design of structure located in vertical prone areas. So, di ba yung paggalaw ng lupa? So, siguro na pag napanood kayo ng Discovery Channel or National Geographic or kay Kuya Kim, di ba meron siyang dalawang klase? Yung meron siyang vertical movement, yung vertical kasi kapag saan nga nangyari? Sa dagat, di ba yun yung nakakapag-cause ng tsunami? Kasi pag umangat yung isang tectonic plate, di ba mag-ano siya? Magkokos na tumaas din yung tubig and cause tsunami. While yung horizontal daw, sabi dito yung horizontal movement yung horizontal component nung paggalaw ng lupa, yung delikado. Lalo na doon sa mga high-rise structure. So ito yung pinag-iigihan na i-consider sa pagde-design ng building sa mga earthquake-prone area. So yung Pilipinas, very prone yan sa earthquake. So during an earthquake, as the foundation of the structure moves with the ground, the above ground portion of the structure, because of the inertia of its mass, resists the motion, thereby causing the structure to vibrate in the horizontal direction. So mag-aaroon ka nga ng swaying. So this vibration produces horizontal shear forces in the structure. For an accurate prediction of the stresses that may be developed in a structure, in the case of an earthquake, a dynamic analysis considering the mass and stiffness characteristic of the structure must be performed. However, for low to medium height rectangular buildings, most codes employ equivalent static forces to design for earthquake resistance. In this empirical approach, the dynamic effect of the earthquake is approximated by a set of lateral forces applied to the structure, and static analysis is performed to evaluate stresses in the structure. So guys, doon sa end ng video may papakita ako sa inyo kung ano ba yung ginagawang test para lang din mas makita nyo yung effect ng earthquake sa isang high-rise structure. Ayan. So, may binigay naman pala ditong diagram. So, in here, this is the initial undeformed configuration, yung naka broken line. So, during the ground motion, kung mapapansin nyo, gumalaw yung foundation mo, and then yung taas nga, halos naiwan doon sa original position niya. So, dito nagkaroon ka ng deformed configuration. Okay. Okay, this time, hydrostatic and soil pressure. So, mas maririnig nyo itong mga term na to pagdating nyo ng soil mechanics and foundation and sa hydraulics na subject. So, dito naman, if this is your surface of your soil or water, so tandaan nyo, habang lumalalim, lumalaki yung pressure niya. Okay? So, ganyan, normally, that is in a prism shape. So, from the top, 0 yung pressure niya, and then habang lumalalim, tumataas yung value ng pressure. So, gamma H yung equation dyan. So, later on, tsaka na siya problemahin kung ano ba yung hydrostatic force or soil pressure na tinatawag. Okay, structure used to retain water such as dams and tanks as well as coastal structures particularly are fully submerged in water must be designed to resist hydrostatic pressure. Hydrostatic pressure acts normal to the submerged surface of the structure, with its magnitude varying linearly with height. Underground structure, basement, walls, and floors, and retaining walls must be designed to resist soil pressure. Okay, so for water, di ba yung mga ginagawang structure dyan is yung mga dam. So, di ba hinohold niya yung water from doon sa kabilang side na hindi maapunta doon sa kabila. So, yan, dyan mo kakailanganin i-design yung structure when it comes to hydrostatic pressure or hydrostatic force. So, pagdating nyo ng hydraulics, magde-design kayo talaga ng dam. So, don't get too much excited kasi darating naman kayo dyan. And isa siya sa pinakamadudugong anyway. So, when it comes to soil naman, so yan naman is yung mga retaining wall. So, ganun lang din yung purpose niya to prevent yung pagguho ng lupa. Kung yung isa pag yung pag-agos ng tubig, yung isa pagguho ng lupa. The lateral soil pressure depends on the type of soil and is usually considerably smaller than the vertical pressure. Okay, so thermal and other effects. So, thermal, ito yung sa ano naman to pagdidesign to ng sa mga bubog kadalasan sa facade engineering. So, basahin na rin natin, statically indeterminate structures may be subjected to stresses due to temperature changes. So, ayun. So, di ba, ano nga ang turo natin sa atin ni mechanics of deformable body? So, pag umiinit, lumiliit. Pag nainit, nahaba. Pag lumalamig, lumiliit na urong. So, naalala ko, dyan kayo tawa ng tawa Hindi ko nga magets kung bakit kayo natatawa nun. Wala akong idea talaga. Okay, so shrinkage of material, fabrication errors, and differential settlements of support. Although these effects are usually not addressed in building code, they may cause significant stresses in structure and should be considered in their design. Okay, so that ends our discussion. So, hindi ata na isama yung sa loading combination. Again, that will be discussed in your higher year subject. So, that is going to be discussed in RCD and steel, structural steel design. So, okay, so that ends our video. So, thank you for watching. And if you like the video, please hit the button like. And if you have comments or suggestions, please write it on the comment section below. Peace out.